Hello dear students, welcome back. In this video we are going to discuss about Bernoulli differential equation. Sometimes it is known as nonlinear differential equation. So let us see first standard form of nonlinear differential equation. So here dy by dx plus p of x y is equal q of x. This is a function of y. I say this is a y raised to n where n is not equal 0 and 1. If n is equal 0, so it is going to be 1. So in that case, it will be what? Linear differential equation. But again n is equal 1, so what we will get? Y raised to n, and this can be written on the left hand side. So again, it will be dy by dx plus p of x minus q of x times y equal to 0. So again it will be what? Linear, and that's why we are assuming that n is not equal to 0 and 1. So in that case this will be what? Bernoulli's differential equation. So whenever you see this kind of the differential equation, first one what you have to follow that whenever we see the differential equation dy by dx, so your dependent variable is y, so we will try our best to remove y function of y from the right hand side. That means I have to divide by y raised to n. So I write that divide by y raised to n. So what I will get? Y raised to minus n dy by dx plus p of x y raised to 1 minus n is equal q of x. Now in the next step what you have to do, you have to consider in the second terms whatever it is. So whatever we have the functions of y, so we will let that y raised to 1 minus n is equal, that is v. So I have to do the differentiation on the both side with respect to x. So what I will get? 1 minus n y raised to 1 minus n minus 1 dy by dx is equal, that is the dv by dx. So from this what you can calculate? Y raised to minus n times dy by dx is equal, this can be written on the right hand side. So you will have 1 divided by 1 minus n dv by dx. Now I'm just replacing over here. So what I will get in the step number 3? 1 divided by 1 minus n dv by dx plus p of x, and this is what exactly our function, that is assumed function v is equal q of x. Now you can observe that v is nothing but dependent variable and it has the degree is nothing but 1. So again this has the degree 1, so therefore this is what? Exactly linear differential equation. So now we can simply solve using that linear differential equation method, and finally we will replace that v is replaced by what? Y raised to 1 minus n, and that will be the final answer. So let us take with this method with the example. So this is the first question. Solve dy by dx plus y by x is equal x raised to cube into y raised to cube. So this is what? Exactly, which is Bernoulli differential equation, that you can see that. So in that case what I have to do, according to step, whatever we have that the dependent variable, that is the y here, so we will remove y from the right hand side. So what I have to do, I have to do the divide by y raised to 3. So what I will get? Y raised to minus 3 divided by dx, and here this will be the y raised to minus 2 divided by x is equal x raised to cube and y raised to cube divided by y raised to cube. So it will be what? Only 1. Now what we will consider, whatever we have that the function of y in the second term, so we will let that is y raised to minus 2 is equal v. So from this minus 2 times y raised to minus 3 into dy by dx is equal, that is the dv by dx. Now I am replacing over here. So what I will get? Y raised to minus cube dy by dx, and that will be what? That you can see minus 1 by 2 dv by dx plus v by x is equal, that is the x raised to cube. Now this is what? Exactly linear. but we know that the standard form of the linear differential equation is what? dy by dx plus p of x y is equal q of x. Therefore, we must have the constant dy by dx as a coefficient, that is 1. So therefore, what I have to do, I have to multiply by minus 2. So I will get dv by dx minus 2v divided by x is equal minus 2x raised to cube, and we will call that this is linear differential equation. If it is linear, so we can find its integrating factor. So from this we can say that p of x is nothing but, that is the minus 2 by x, and q of x is nothing but minus 2 times x raised to cube. So here we can find that the integrating factor. So here integrating factor will be e raised to integration p of x dx. Therefore, e raised to minus 2 by x dx, and that is same as minus 2 integration 1 by x dx. That also you can write that minus 2 times ln x. So from this you can say that x raised to minus 2, but also this can be written as 1 divided by x raised to q, and that is our integrating factor. So now we have the q of x. So let me write that the q of x, that is q of x is nothing but, that is the minus 2 times x raised to cube, that you can see. Now therefore the general solution, general solution is given by dependent variable. So we have already mentioned that v is nothing but dependent variable. So dependent variable v is multiplied with the integrating factor is equal integration q of x multiplied with the integrating factor dx plus c. But here integrating factor is nothing but 1 divided by x square. So I write it over here, and integration q of x, that is the minus 2 times x raised to cube, and integrating factor 1 divided by x square dx plus integrating constant c. So after simplifying, what you will get on the x, so integration will be x square by 2 plus c. So what you will get minus x square plus c, but v is what exactly, what we have taken, that v is equal, that is v is nothing but y raised to minus 2. So what we are taking here, that we are assuming that the y raised to minus 2 into 1 divided by x square. So you can observe that 1 divided by x square y square plus x square is equal c, where c is nothing but constant, and this is known as general solution, and that is your final answer. Let us move on to the new question. So very quickly, so you can say that here given differential equation has the dependent variable, that is the y, and whenever we see this kind of, so here it is the e raised to y, so we can say that this is the non-linear. So particular what we can say, which is the Bernoulli differential equation, so which is Bernoulli type differential equation. So what I have to do, first I have to remove functions of y from the right hand side. So first I will write that the divide by e raised to y. So what I will get, e raised to minus y dy by dx plus e raised to minus y times 1 by x is equal 1 divided by x square. So from this it is clear that from the second terms functions of y, so we are letting that e raised to minus y is equal v, so e raised to minus y into minus dy by dx. Why we are taking that here minus? Because derivative of the minus y is nothing but minus, and times dy by dx is equal dv by dx. So whenever I suppose to replace e raised to minus y dy by dx, so I will use minus times dv by dx. So therefore our equation number 1 reduces to, equation 1 reduces to minus dv by dx plus v divided by x is equal 1 by x square, and this is what exactly linear differential equation. So let us write here minus dv by dx plus v by x is equal 1 by x square. Again this is the linear, but I want coefficient as a plus 1, so I will write multiply by minus 1 So I will get here dv by dx minus v by x is equal minus 1 divided by x square, and this is the linear. So we have that the p of x is nothing but minus 1 by x and q of x is nothing but minus 1 divided by x square. So therefore the integrating factor e raised to integration p of x dx. So here p of x is nothing but minus times 1 by x dx. So whenever you do the integration, so you will get e raised to minus ln x. So this is the e raised to ln of x raised to minus 1. So you will get 1 divided by x, and that is what our integrating factor. So therefore the general solution, dependent variable is multiplied with the integrating factor is equal integration q of x multiplied with the integrating factor into dx plus c. So here write that the integrating factor, that is the 1 by x, but q of x is minus 1 divided by x square. 1 by x integrating factor is there. So what you will get whenever you integrate, that is the x raised to minus 3. Let me write the one more step so it will be clear to all of you. So we are using that the formula. So x raised to minus 3 plus 1 divide by minus 3 plus 1, and that is the integration formula. And after finally what you will write that v divided by x is equal minus x raised to, that is the minus 2. So we will write that the x square, and minus 3 plus 2, that will be the minus, so minus minus plus, so we will have this one. But now v is replaced by what? E raised to minus 1, as already we have taken that v is nothing but e raised to minus 1. So I'm just going to replace it. So I will get that the e raised to minus 1 divided by x is equal 1 divided by 2 times x square plus c, where c is nothing but arbitrary constant, and this is known as general solution. So in this video we have discussed about the non-linear differential equation. It is known as Bernoulli types of differential equation. Thank you.